Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben uw gastheer Ronald Kers en ik zit zoals altijd met de enige echte...
Hallo Ronald.
Jan Stomphorst.
Hey, we zitten nog steeds in de Dome. We zitten nog steeds op DevWorld.
Ja, top. Echt. Het blijft een fantastisch event om hier te mogen meemaken. Ja,
Ja, en ik hoorde net, wat wel leuk is dat als de speakers die praten, hebben ze hier allemaal koptelefoons. Dus die events zitten best wel dicht bij elkaar.
ja
Dus-
het zorgt ook wel voor een bepaalde rust in het event. Weet je?
Ja.
Je hebt niet overal die herrie die we wel eens vaker mee hebben gemaakt op andere events. Dus dat is wel
Dat
cool.
is wel, dus in ieder geval,
Ja.
geklap is altijd goed. Maar we zitten hier met een gast, hè?
Ja, zeker. Dat is Adrian Precub.
Yes.
Okay, welcome for joining us, Adrian. Thank you for taking your time. And well, for the people who don't know you yet, can you please introduce yourself to our listeners?
Yeah, sure. So I'm a staff engineer at TomTom, where we develop maps and navigation and other services. And I've been a software developer for more than 15 years with various technologies, Java, Scala, which, by the way, I think it's just invented to talk to aliens. So, yeah, I think that should be.
Yeah, and how did you get started in the IT? What's your history? A little bit.
So the history in IT, I started in 2007. Then I joined IBM. At some point later, I became very interested in backend systems, so mainly Java. Joined the Electronic Arts for a couple of years to help with, well, mainly FIFA, if you think about it. I don't play myself, but I did work on that game. And then I moved to Netherlands, where I am now a staff engineer at TomTom.
Okay.
Cool.
I think everybody knows TomTom. I don't. Everybody knows TomTom from the past, but yeah, because we've got.
Everybody had the little boxes in the car.
Yeah, everybody had TomTom, and we've got a lot of commercials about TomTom. But is TomTom still great? In what's TomTom doing at the moment?
So right now, of course, if you think about the evolution of technology, you won't really see a lot of PND devices in the cars anymore, right? Because you have your phone. On motorcycles or trucks, right?
Yeah.
Or fleet management, if you think about it. But also, TomTom had to expand its business to more enterprise and manufacturers, right? So there is a lot more business going on than the PND devices that people know TomTom. Of course, we also have applications in the App Store and in the Play Store, like GoNav and Nav SDK and all these stuff that were developed behind the scenes, but are made available for developers to develop their own navigation applications.
Awesome.
Yep.
So they're still big. Yeah, yeah, that's awesome.
And can you tell a little bit about the journey of TomTom into the Kubernetes landscape?
So in TomTom, I joined 2 years ago, so maybe I don't have the full history, but there are a lot of teams running Kubernetes clusters on especially Azure Kubernetes services. My team is one of those, so I work in the access management service team. So we have a cluster right now of about 40 nodes. So to leverage all our authentication and authorization calls that come from the cars towards our services, everything goes to the AMS access management service. So then you can imagine there are a lot of calls and
exactly
in the domain of thousands. So,
Yeah.
per second.
So you have a talk about TCP packets
Yes.
here later.
I have a talk about how basically one single packet from a specific type of request managed to bring down 3 big data centers of a firewall, which
Interesting
I will
story.
not name. But yeah, so in this investigation, we had to do some TCP captures on Kubernetes, and as we all know, not that easy to do. Easy on a VM, very easy, TCP-dump, but on a Kubernetes cluster, it's a whole different thing. If you want to capture all the nodes at the same time.
Okay.
So then we had to develop some custom scripts and some tools to do that.
First thing I want to know, how does a TCP packet destroys firewalls?
Not destroy, but bring down so that it cannot make any other outbound connections.
Okay, but
So it's a bit of a preview from the talk, but basically, if a reset packet, which was the case for us, a reset packet does not go from start to end. In a firewall, this reset packet is blocked, and if that firewall connection has a timeout of 1 hour, you cannot reuse that port, that's not port, to make any outbound connections for that reset packet. So then if you have hundreds of thousands of those reset packets, they will occupy all the SNAT ports, and then everything will be blocked for 1 hour. So, and that way, and it doesn't matter how many ports you have and how many VMs,
packets will
because
keep on
all
coming.
of them keep coming, and then all of them occupy a different SNAT port. So then all the ports in that firewall, data center, they will all be used for 1 hour.
Oh, wow.
Until that timeout is cleared, and then, of course, you will see. Okay, so now we can make requests, but actually it will be again the same. So you have a spike of it because every port will be freed after 1 hour, but then you also have a dip because it will also be occupied for 1 hour again.
Again, yeah, exactly, yeah.
Yep. So this is a sort of a preview of the talk, but that's
awesome.
You learned the hard way, then?
The very hard way. Yes.
Yeah.
Okay, and then you're capturing those packages in Kubernetes. Because that's difficult.
It is. Yes.
How do you do that?
So we have, it's actually a custom script, a bash script that goes through each Kubernetes node and does a capture for it, and then brings all of that together into the number of nodes that you have. You will have the same number of captures, and unfortunately you have to go through all of them to figure out, where is the issue. Is it maybe replicating on all nodes or maybe some nodes? And this also goes like if you have an Nginx ingress-controller, which we did the capture only for nodes that contain the pod with that Nginx ingress. So then maybe you don't have 40 or 100 nodes, you just have the number of nodes that you have Nginx ingress controllers. So then it's a bit more less in scope, but it also gives you a big overview on what number of requests are coming in and if there are actually some issues in those TCP packets, right? End to end.
Yeah, so I have also a question. If of all the firewall ports are blocked, how do you keep the management part up? Because if all the traffic is blocked, different IP address.
So the firewall was actually not part of our team. It was an external party. You know about it, but I will not name it. So it's actually an external firewall, and we don't have control over it, right?
Okay.
It's just that from the investigation, we found out through the TCP captures, we saw, so we see this IP, but this IP doesn't belong to us. It belongs to somebody else.
Yeah.
Right? So then, this IP sends the packet, and then the reset packet is seen on one part of the firewall, but maybe not on the other side.
Yeah.
And then so tracking down these TCP captures from the car to the firewall to the AMS in TomTom was a huge investigation that, eventually it turned out that one TCP packet was able to bring down 3 data centers.
Yeah. I see you thinking.
No, I'm thinking all the time. Back to capturing. You had a great question, but back to capturing. You said we're running that on the nodes.
Yes.
But are you using the AKS or are you rolling your own Kubernetes?
So we use the AKS service, which provides the control plane, and we created using two node pools. One is the system node pool, as Azure recommends, right? Which handles everything from metric server to other control plane pods. And we also have a user node pool, which we use to deploy our applications. Right. So, and in this user applications node pool, we encountered this issue.
Okay. How do you do the capture then? Because normally you don't have the access. to...
You don't have the access. So
nodes.
there is a, I can't remember the Docker image from Microsoft, but there is a documentation in Microsoft, and I have an article about it, and all the scripts in the talk. There's a QR code that you can scan and go see it. But basically, there's a Docker image from Microsoft which allows you to connect to the node and do TCP captures on that.
Okay.
So you...
That's useful information.
That's useful information.
Yes.
We'll include that in the notes, in the show notes. But that Docker needs to run privileged.
You need to provision it. So
container.
So you basically create a new namespace in your user pool or in your right. So you create a namespace, you deploy these pods, and the number of let's say call them debugger pods, they will be the same number as you have Nginx pods, right? So then each debugger pod will run a TCP capture on a Nginx pod.
Okay, but you've got and you wrote a script to detect where the pod of the Nginx is.
Exactly. Yes.
And then run that pod. So it's not a daemon set.
It's not a daemon set, no.
But it's connected to that node. So you did node identifier.
Yes.
Called.
Yeah. So it's basically think of labels, right?
Yeah,
so
node labels.
So if we see a label which contains, let's say, Nginx, we say, okay, this node contains Nginx pods. It doesn't matter how many of them, we iterate, right? So all the Nginx pods that are deployed on that node will have a TCP captures done for them, right?
Okay. So then you trace the packet, you know where it is, and how do you prevent it from happening again?
So that actually know where the packet is, that is the investigation that took a long time. How do we prevent it? It was a fix done by the firewall company, and it is not something that we were allowed to to see. But however, they used the data that we provided, in which we said, hey, you know, you have two parts of the firewall. You have the input and the output. We see our reset packet on the input, but not on the output, right? Yeah. So that means that connection will remain open on your side. And with this information, they went ahead and they put a fix, and then they basically allowed those TCP packets, those reset packets to pass through from the inside to the outside.
Yeah, sure.
And the reason that this reset was not passing was because of a short delay of a couple of microseconds in the reset packet. So if you think of TCP, right, it works on a three-way handshake, and so we basically know all of that. But we also know that the TCP packets can be retransmitted, right? Yeah. So if you get that retransmission and the packet arrives a couple of microseconds after, or earlier, then that packet is considered stray by the firewall, and it's like, okay, so maybe you want to do an attack.
Yeah.
Right. So so then the firewall is like, okay, I'm not sending this from one side to the other.
Mm.
Yeah. So that was the. But for the connection on the firewall to be closed, they needed that reset packet from the inside to be passed to the outside.
Yeah. Cool. If you do a dump on every node, like for example, you've got like 5 Nginxes running on 5 nodes. It's going to be a lot of data.
It's going to be a
lot of data.
Yes.
Where do you store that data?
So first of all, we don't do the TCP-dump for everything. We know the IPs that call us, right? So we basically sort of limit that capture. But even so, it will be like in maybe 30 seconds to 1 minute, you can have files of 1 gigabyte.
Yeah.
Right. So there's not really a way that we didn't investigate how to limit more these captures, because we actually didn't know what data we needed.
Yeah.
So we did have scripts that were returning 1 gigabyte files, and then we had to analyze them one by one. So it was, there is a way to put all of the files together, but the problem is when you try to open the 5 gigabyte file of TCP capture, then you will have a problem in Wireshark, right? Because Everybody knows
But
Wireshark.
you did not automate it.
You can see the not responding message.
Exactly.
Appearing.
Exactly. Yeah. Right.
You did not automate it like with an Kibana, an Alec cluster.
No, we didn't spend time on that one because this issue was so niche that once we found out that this problem, we didn't see feasible to say automate any of this because it's so rare that this happens. So yeah, I mean it can happen again. So we have the scripts that help us identify, but not automate.
You're not running this full time.
No.
Okay, just we see a problem, we still a package dump, and then
Exactly, yes.
for that pod, why are you not doing the package dump in the pod?
In the pod itself.
Yeah,
Because so if you think about
or
it,
before the pod. Like if you do, like an NVO and sidecar to route the traffic to like a service mesh.
so we have SSL termination done on Nginx.
Yeah.
So then we needed to know if the SSL termination is successful and if the TLS handshake is actually established correctly. And by the way, this was the problem. So if you have layers for the network, right? So it goes from the Wi-Fi to the, I don't know, IP, and then to the, what it's called, the TCP, right, stack. After that, you have the TLS handshake.
Yeah.
And if this one fails, you won't have any HTTP metric in your monitoring. So you don't see it as a one request, one HTTP request, because it doesn't get to the application layer,
Doesn't get there. Yeah.
which is HTTP. So all of these requests that we were seeing after we know the issue were not showing up in our Grafana as incoming HTTP requests because they failed.
But if you're now doing the IP package on the node, on the specific nodes, on the specific IP addresses,
Yeah.
but it's traffic to Nginx, and if you well, just thinking about it, if you capture the traffic to that Nginx pod, you would get the same result, or not?
You would get the same result, but for us it was important to know that it is not traffic that we messed with. So it is the actual real life traffic. So you can have sidecars in which you maybe redirect traffic, or but then you have to kind of sort of mess with the real traffic, right? To switch to, it's like a train, right? You put to one track or the other.
Pushing the traffic through and sidecar.
Exactly, but I think that's exactly what this Microsoft image does. So it does the capture on the Nginx pod, but it's connecting from the pod of the debugger pod, right? That you spin up. So it's not rerouting any traffic. It's waiting for traffic to arrive to Nginx, and then on the Nginx I'm doing the TCP capture. But you're not actually doing the SSH yourself, or the kubectl to the pod itself.
Yeah, he's our solutions architect, so
Yeah.
He's thinking about solutions of how we would approach
I
it.
was thinking about how would you do it, and I'm very interested to play with this because it's a common theme. If you want to do package, I want to do package dumping for my application sometimes.
Yeah.
And often I use a service mesh like an Istio or a Linkerd to install that, and then I can do. I'm getting more information.
We don't have a service mesh. So,
Yeah, of course.
so that's why I think if you have a service mesh like Linkerd or Istio, it makes things way more easier. But we didn't have that.
Yeah.
So for us, it was not that easy to reroute traffic, right? Or to create that proxy you were discussing, right? It's a bit more difficult. So we just had directly Nginx ingress-controller, which routes traffic to the application pods, right? Yeah.
Okay. Yeah. And You started. You weren't with TomTom that started with Kubernetes, but why did TomTom choose for the Kubernetes solution?
I think one of the main reasons was because it's cost effective, right? You don't need VMs for every application like you need on-prem. You can also, of course, go to Azure and say, I have this service, I want 3 VMs and make it highly available. Yeah. But I think it's also important to have like the metrics that Kubernetes provides by default. Well, not by default. You need Prometheus for that. But I think the insights that you gather from a Kubernetes cluster are much more valuable than trying to make the same insights but using VMs. So we kind of have a standard, like if you create a Kubernetes cluster, you need to create a certain standard for metrics. Like you need to monitor the nodes, you need to monitor the pods, certain CPU, memory, and so on. But also HTTP requests, which is application metrics. And failed or 4xx requests. What happened? Maybe the client is making a lot of wrong requests. Yeah. Or 5xx, which is the server saying, okay, I don't know what to do, or So I think in Kubernetes this is much easier than with regular VMs. And then of course there's log aggregation, right? So you can basically have an agent which is installed and takes all the logs from all the pods and puts them in one place, right? So
are you using the Azure solution for that?
We're using a different solution, but it's basically the same concept. So we use Scalar, but it's pretty much the same concept, right? Log aggregation, Prometheus for metrics and Grafana for visualization.
So you're also not using the Azure components to measure your.
Not really. So we basically don't use. We use the Azure Kubernetes service, but not all that it provides as the whole, service offering. We just provision the cluster and then we put ourselves, monitorings, logs, and all the other, and deploy the services ourselves. And we use Azure pipelines for that, right? So,
Azure DevOps?
Yes.
Oh,
yeah.
Sorry.
I know.
I'm sorry.
We're in the process of moving to GitHub Actions. GitHub Actions.
GitHub, that's much better.
Yeah, so we are in the process.
What you often hear is also when there is a problem and you don't know where it's coming from, you have to search for the problem and you discover that there is a container image from Microsoft you can use to access the nodes, right?
Mm-hmm. Yeah.
Are there any other things you have discovered during the problem solving that could be useful to know for our audience and the people to look at, you can share?
Yeah, so other tools, I think everybody familiar with TCP-dumps knows Wireshark.
Sure.
Yep.
Right. I think one important thing that can help if you have small captures is that you can merge together those, let's say, a couple of TCP captures, and it's easier to follow the capture. Yep. I think also it's very important when you do a TCP capture to limit the output, because that is like the huge killer, right? So if you have gigabytes of TCP dump, it's very difficult to go through them. Yeah. And that's what we try to also achieve. So we put filters for the, let's say, the firewall IPs. We put filters for the TomTom IP. So it was actually narrowing down it, but also if you have, like in our case, thousands of connections per second, you will have millions of packets, right? Because each HTTP connection actually doesn't have only one TCP packet. It has like a whole list, and then you have to follow all of them. And of course, traffic is encrypted, and then you have to say, okay, well, I guess that this request does this, right? So. I think that was the most, limiting your TCP dumps to a size, to a manageable size for the reader.
Right.
Yeah. That's really old school.
Yes.
In the past, we all did TCP dumps on every machine, constantly.
Yeah. brings back memories.
Yeah, yeah, but it's
But nothing really changes, you know. Only it gets smaller and smaller, but everything stays the same.
Of course, the infrastructure did change. Like we don't do it on VMs, we do it in Kubernetes cluster, but the process is the same.
Yeah, but before VMs, it was machines.
Yeah,
you know, so
bare bone.
Yeah, but in the end, everything stays the same.
Exactly.
Yeah. Well, to round this up, we always have a final question, and that is, how do you foresee the future of Kubernetes? So imagine you have a crystal ball right here,
all right,
and what do you see, or do you want to see in the future?
All right, so I'll start with what I want to see. So right now, if you ask some, I don't know, let's say beginner in Kubernetes world, how do you start with Kubernetes? So they will have to go and search a lot of things on Google, and maybe some things work, some things change. I think one of the most important part is that you have a very easy startup process. So without all the details of control planes, of this was the case for Azure, but user nodes and system nodes and all the other things that are not really needed if you're just starting, right?
Sure.
So that part I think would bring more people to say, okay, well, I can give it a shot. You know, it's just maybe 1 hour of doing things
and
lower the barrier to entry, because then people will get curious and it's like, oh, okay, so I have this centralized thing. It gives me metrics, it gives me logs, and everything centralized. So then I can dig a bit more and say, okay, so there's a control plane that does this and all the things, right? So I think lowering the entry barrier for newcomers would make a huge difference into more people adopting Kubernetes. And for the other part, which one was it too? Where I see Kubernetes going? I think it is going in that direction of easing the entry barrier, but at least to my opinion, a bit slow. So you have all the three major cloud providers having this, but they all have varying difficulty to basically provision a cluster and use it in production, right? And that's I think also a very important part. It's easy a bit much to say, but you can get into the Kubernetes, but can you get into running Kubernetes in production easy, right? And that part, like if you think of Spring Boot, right? Spring Boot is sort of production ready the moment you create your application.
Okay.
Right? You have the metrics, you have the statistics, so there's a lot of things that is provided to you. But if you start with the Kubernetes in Azure, is it production ready? Maybe
I have to look to my
you have to enable some log services, you have to enable some metrics, maybe I didn't use all the services that Azure provides. That's of course, but I think that part where you have everything contained and it says, okay, this is production ready. I would like to see that.
Ready. Yeah. Because Azure solves a lot of problems for you in that part. I don't like them, but that's my problem.
Because it's a Microsoft solution.
I don't like them, but that's my problem. I like the Prometheus stuff, and that's it's a great way to go. But it's more difficult, Jen.
Yes,
I understand.
Exactly. But maybe in Azure, I don't know if it's the same or not. But you have to enable, so for metrics you have to enable some service, or for logs some other storage account. Exactly, right? So that's what I mean, right? If you have it doesn't matter who you are, Amazon, Google. So if you have one click, right? I click this, I have everything, and then you have the dashboard with nodes and logs and metrics. I think that maybe would be a good idea for newcomers to maybe do a production-ready application in 2 hours.
Okay, cool.
Sounds the way to go.
Yeah, thank you very much.
Thank you very much, man, for your time, and we look forward to joining your talk tomorrow, right?
Tomorrow.
Okay.
Yeah, we'll have a look. And people, don't forget to subscribe.
Like and subscribe. Where can people find you?
So I'm on LinkedIn, Adrian Precub. I will have also the QR codes for the...
Also on LinkedIn? We'll put
Yes.
it on the... Okay,
Sure. Okay.
Yep.
Nice.
cool. Thank you very much.
Thank you very much, man.
Thank you.
Okay, see you.